Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email, and yeah, to schedule your class. So with this, let's get started with this paper. Thank you.
Hello everyone, welcome back to my channel. Today we'll be solving the Math EEHL Paper 1 of May 2025 attempt and of Timezone C. And let's get started with the first question. We have log base 10 2sp and log base 10 3sq. We need to find the expression of log base 10 24. So we can break down log base 10 24 like this. Write it as log base 10 8 times 3, right? Then I can write it as log base 10 8 plus log base 10 3 because log a plus log b equals log a times b. Then I can write 8 as 2 cubed log base 3 and 10 3, which gives me 3 log base 10 2 plus log base 10 3. Now log base 10 2 is p, so it's 3p. Log base 10 3 is q, so it's q. So 3p plus q would be the answer to part A. Now moving on to part B, we have to find the expression of log base 3 8. Now for this, we have to use the base change formula of log, which will give me log base 10 8 divided by log base 10 3. This is the base change formula for log. And similarly, log base 10 8 can be written as log base 10 2 cubed divided by log base 10 3, which can be written as 3 log base 10 2 divided by log base 10 3. So numerator becomes 3p over, and the denominator becomes q. So 3p over q is the answer to part B. Now let's move on to the next question. So we are given the graph of y equals fx, and the domain is between from -6 to 5. Fine, we have to find the value of f of -3. So if we go x equals -3, go to the curve, the corresponding y value is -1. So for part A, f of -3 becomes -1. Now we have to state the domain of f inverse x. Now, remember one thing, range of fx is equal to the domain of f inverse x. Range of fx is in between 5 till -3. So we'll just write it like this. Range of fx is y less than equal to 5, greater than equal to -3. So range of f inverse x, this will be -3 less than equals x, less than equals 5. Right? Or I can write it as x belongs to -3, comma 5. This is the answer to part B. Now coming to part C, we have to find the value of x that satisfies f inverse 2x minus 7 equals -3. For this, as it's an equation, I can take fx on both sides. So f of f inverse 2x minus 7, this will be f of -3. So f of f inverse 2x plus 2x minus 7 gives me 2x minus 7 only, and f of -3 is -1, which we found in the first part. The 2x would be 7 minus 1, which makes it 2x equals 6. And finally, from here, we get x equals 3, which is the answer to part C. Now, coming to question 3, we have to solve this trigonometric equation where you have 2 cos 2 theta minus 5 cos theta plus 2 equals 0. But theta should be between pi and 2 pi. Fine. So when we start with this equation, I just have to expand cos to theta, which is 2 cos squared theta minus 1. This becomes 4 cos squared theta minus 2 minus 5 cos theta plus 2. Now the negative and positive 2 will cancel out. And if we take cos theta common, we get 4 cos theta minus 5. Now from here, two solutions are possible. Either cos theta would be equal to 0 or 4 cos theta minus 5 would be equal to 0. The right one will give me cos theta equals 5 over 4. Now, as 5 over 4 is bigger than 1, cos theta can never attain this value. Okay. So cos theta will not be equal to 5 by 4 because maximum value of cosine theta is 1 and minimum value is minus 1. This value is bigger than 1, so of course, not possible. Now, cos theta equals 0. The principal solution of this is pi by 2. Yeah. But we want the solution between pi and 2 pi, right? So our actual answer, theta, would be pi plus pi by 2 because the value will repeat after pi. This is 0. It's just 3 pi by 2. And this is the answer of question 3. Just one solution. Now moving to question 4, you have a quadratic x squared minus x minus 1 and a line y equals mx minus 3. Now you need to show that curve and line meet when x squared minus m plus 1x plus 2 equals 0. Okay. For the first part, when two curves meet, their y coordinates become equal. So you can just equate these two parts. X squared minus x minus 1 equals mx minus 3. So if I shift everything to the other side, I should get this equation. Then from here, if I take negative x common from these two terms, I'll get 1 plus m here. And minus 1 plus 3 is 2. Now this is what I have to prove. They have just placed the x here. I just placed it in the front, but exactly it's the same equation. Now the next part. Find the values of m when line is tangent to the curve. Okay. When the line is a tangent, there's only one solution. And in a quadratic, you get one solution when the discriminant becomes 0. Okay. B squared minus 4ac would be 0. Here, b is minus 1 plus m. Minus 4a is 1, c is 2. So the left side is m plus, can write it as m plus 1 whole squared minus 8 equals 0. M squared plus 2m plus 1 minus 8 is 0. And then if I simplify it a bit, I get this equation. As it's a quadratic, again, I can have two values of m. So basically, for two values of m, or you get two lines which are actually tangent to the curve. So m would be minus b root under b squared minus 4ac divided by 2a minus 2 plus minus root. Inside the bracket, I'll get 32. 4 plus 28. 32, I can write it as 4 root 2. So finally, I get minus 1 plus minus 2 root 2 as m. So the slopes would be, or the possible values of m would be minus 1 minus 2 root 2 or minus 1 plus 2 root 2. And that's the answer to part B. It says values, so they were expecting two values. Now the next, this is a normal distribution question, which is generally not expected in paper 1, but yeah, this one turned up. So we have two random variables, x and y, which are normally distributed when x is a normal distribution with mean 7, standard deviation a, and y is 19 and a squared. Okay, fine. We have to find b such that x greater than b equals y greater than 22. And we can just standardize these two and equate the rest. So, when we standardize the right side, z would be 22 minus the mean is 19 divided by a, which is 3 over a. And when we standardize x, z would be, this is b, right? So b minus 7 by a would be the z value of x. Now, I can write this equation as p of z greater than b minus 7 by a equals p of z greater than 3 by a. Now, as everything is equal, I can directly equate these two parts. B minus 7 by a equals 3 over a. The a in the denominator gets cancelled out, so b becomes 7 plus 3. So b is 11. Oh, sorry, 7 plus 3 is 10. So for part A, the answer is 10. Now moving on to part B, we have to find the approximate value of 7 minus a less than x less than 7 plus a to two correct significant figures. Again, we can just standardize this thing. The first one is 7 minus a. So 7 minus a minus 7 divided by a. So this 7 and minus 7 cancels out. So minus a over a is minus 1. And the other one is 7 plus a. 7 plus a minus 7 by a. 7 cancels out. A is 1. So this can be written as minus 1 less than z less than 1. Okay. So basically, this will be equal to 0.68. So we get this. So there's a general information which we need to know. 68% of data within one standard deviation on a normal curve. And then the answer is 0.68. Now moving on to the last part. Given that a equals 3, calculate the approximate value of p y less than 22, correct to two significant figures. So 22, so it's again one standard deviation. We can just standardize it for our sake. And we standardize y, 22 minus 19 divided by 3, which is 1. So we have to, less than 22, this will be p of z less than 1. P of z less than 1 is 0.84. Again, a standard result, which may be remembered. And with this, we are done with question 5. Now moving on to question 6. We have to consider the function f. The graph of f has a local maxima -1, minus 5 by 2 and minimum at 0, 5 by 2. There's a vertical asymptote at -1 by 2, the oblique asymptote 5x plus 5. The graph is given, and guess what? We need to graph f of mod fx and 15 by fx. Let's start with mod fx. So the idea is anything above the x-axis does not change whenever you're replacing mod. The stuff below the x-axis will get reflected above. The vertical asymptote remains the same. There won't be any changes with it. But there'll be a change in the oblique asymptote. Oblique asymptote was 5 plus 5x, right? And it will become yeah, mod 5x plus 5. Fine. That means at -1, there will be a change, right? So to find this, when we place x equals 1, it's 10. So there is 1 point here. And yeah. So if I connect these two, this is the first part of the oblique asymptote. Wait. Just fix it a bit. Done. And for the other part, if I take -1 is 0, if I take minus 2, it'll give me 5, right? 5 is somewhere here in between 6 and 4 and 6. We can just connect them like this. Yeah. So this becomes your asymptote. Now what happens to the curve? The curve, this part remains the same. So B will be somewhere here. Yeah. And the curve come down like this. And then it'll become an asymptote to this oblique line. Yeah. For the other part, the point A, which was here, it'll get reflected above the x-axis. So you see, it's just a little bit below -2. So here, the y-coordinate will be a little bit above 2. This is 2. So somewhere here, we'll have A. Obviously, the x-coordinate remains the same. Only the y1 will get reflected. Now we can just connect them. So this is the asymptote. We'll come here. Just connect it like this. So this will be the mod fx curve. Nothing, just that the curve below the x-axis got reflected above. Now the next one, we have to sketch 15 over fx. So 15 over fx, this one thing is very important, that the vertical asymptote of fx becomes a 0 of 15 by fx. So at x equals -1/2, there is a 0 or there is a root. Fine. Next, as this tended to -infinity, the left side, and the right side tends to infinity, 1 by -infinity is a value a little bit smaller than 0. And 1 by infinity is +0. This curve will, okay, at the end, x tends to infinity will be y tends to 0 plus x tends to -infinity, tend to y tend to 0 minus. So the curve will end here and here. Fine. This point was a maxima. This The maxima will become minima. So A was a maxima and E will become a minima before becomes a minima. And we need to find the coordinates of A. So the x coordinate will remain -1. To find the y coordinate, it's A is -5/2, 15 divided by -5/2. No, wait, 1 second. That's, yeah, 15 by -5/2, correct. So A is -6, basically. -1, comma, -6. So here you have point A. Similarly, B, which was a minima before, becomes a maxima. Okay. So B, the x coordinate, remains 0. The y coordinate of B was at 15/2. So 15 divided by 15/2, it becomes 2. So the coordinates of B would be 0, comma 2. So B would be here. And B becomes a maxima, A becomes a minima. So the graph probably will go like this. Right. This, then this, then this, and then it'll become an asymptote. Go like this. This is the curve of 15 over fx. Done. Now coming to question 7. Yeah. We have v equals, yeah. We have this curve x squared plus y to the power of 4 r to the power of 4. X is between 0 and r squared. But the region enclosed by the curve and y-axis rotated through 2 pi forms this solid of revolution. Find the expression for volume. Now let's find the y-intercepts. X equals 0 at these 2 points. So y to the power 4 becomes r to the power 4. So here y would either be r or y be minus r. So this point is y equals r, and this point is y equals -r. Now we are revolving it about the y-axis, not x-axis. When the volume of revolution is done about the y-axis, the equation would be f of y whole squared dy. Okay. Now we just have to place values and then simply integrate and we'll be done. So x would be x squared from here. This was to find y. Now from this curve, x squared plus y to the power of 4 was r to the power of 4, right? So x squared is r to the power 4 minus y to the power 4. So x is, yeah, x is basically your fy, right? So we can just use this equation. So x squared is fy whole squared. So limits would be from minus r to r, and this would be r to the power 4 minus y to the power 4 dy. Yeah. Now, finishing this integral, this will be r to the power 4y minus y to the power 5 over 5 r negative r. Okay. When I place y as r, it becomes r to the power 5 minus r to the power 5 by 5. When I place r as negative, y as negative r, it becomes minus r to the power 5 plus r to the power 5 by 5. When I open this bracket, negative r to the power 5 becomes positive, so if I can directly simplify and make it twice r to the power 5 minus twice r to the power 5 by 5. And yeah, if we simplify it from here, it becomes 8 pi r to the power 5 over 5. So comparing with this form, A would be 8 over 5 and B would be 5. This is your answer. That's all about question 7. Let's move on to question 8. Yeah, so they have given us a complex number z1 equals root 3 minus 3i. We have to express z1 in the form r e to the power iota theta. So r would be root under root 3 whole squared minus plus of negative 3 whole squared, which gives me root 12, basically, which is 2 root 3. Done. Now we have to find the argument or theta. Now here, locate this point. This is root 3. This is negative 3, right? There's a point. We'll first find this angle alpha. Tan alpha will be root 3 over root 3. If I just take the length, this length is 3 and this length is root 3, not taking signs, just the length. So root 3 over 3, which gives me root 3. So alpha is tan inverse root 3, which is pi by 3. Now arc z, which is theta, would be 2 pi minus alpha, 2 pi minus pi by 3. Because argument is the angle which is calculated from the positive x-axis in an anti-clockwise way, right? If you go this anti-clockwise, you get this one, this angle, which is 2 pi minus pi by 3. So which gives me 5 pi by 3. So z1 would be 2 root 3 e to the power of 5 pi by 3 iota. This is the answer for part A. Now part B, you're also given z2, right? Similar e to the power iota theta form. You have to find the cube roots of z2 over z1. Fine. Now z2 over z1, let's say z3 is z2 over z1. 2 root 3 e to the power iota 5 pi by 6. 2 root 3 e to the power iota 5 pi by 3. Cancel these two out. And then when we subtract the powers, 5 pi by 6 minus 5 pi by 3, I get z3 as e to the power negative iota 5 pi by 6. Now, when we find the cube roots of z3, so the um, modulus is 1, right? So root cube of 1 is 1. But the other part will go like this, that theta plus 2k pi by 3, where k would be either 0, 1, 2. Right? So cube roots, so you'll have 0, 1, and 2. So z1, so let's take u as z1. z1 would be e to the power iota minus 5 pi by 6 plus 0 divided by 3, which upon simplification gives me e to the power iota negative 5 pi by 18. That's our first root. And this corresponds to k equals 0. The next one, z2. this will be e to the power of iota minus 5 pi by 6 plus 2 pi divided by 3, which upon simplification gives me 7 pi by 18. E to the power iota minus 5 pi by 6, then if k is 2, it will become 4 pi, which is e to the power iota 19 pi by 18. This k equals 2. So these are the values of u, v, w, which are the three cube roots of z2 over z1. Now here we have a limit question. For this, we first place the value of x and check the form of the limit. So 0 sine 0, 1 minus cos 0, which is basically 0 over 0 form, right? If it's 0 over 0, we can apply the L'Hopital rule. We apply the L'Hopital rule. I'll first differentiate the denominator. Differentiation of x sin x. First different is you have to apply product rule. First differentiate x, keep sin x constant. Differentiation of x is 1. Then keep x constant, differentiate sin x, which gives me x cos x. And differentiation of 1 minus cos x is negative of negative sin x, which becomes positive sin x. Yeah. Now, if you still place x equals 0, you get 0 by 0 form. Because the denominator is 0, sin 0. Numerator is sin 0 plus 0 times cos 0, which is again 0. So we have to differentiate it once again. Sin x is cos x, then differentiation of x, cos x remains constant, and then you get negative x sin x, and differentiation of sin x is cos x. Now when I place x equals 0, cos 0 is cos 0 minus 0 sin 0 by cos 0, which is 1 plus 1 minus 0 by 1. And finally, the limit becomes equal to 2, which is the answer to part 9. Now moving on to section B, let's start with the first question. So here you have a sequence un, and term is given by un. The first three terms are k minus 5, 3 minus 2k, and third one is 5k plus 3. So we have to consider the case where un is arithmetic sequence. We have to find the value of k. So in that case, we can do u2 minus u1 equals u3 minus u2. Because u2 minus u1 is the common difference t, same for u3 minus u2. So common difference has to be equal. u2 minus u1 will be 3 minus 2k. U1 is 5 minus k, so minus k plus 5. U3 is 5k plus 2. U2 is minus 3 plus 2k. Then we need to simplify this. This side is 8 minus 3k. The right side is just, yeah. Mm, okay, this is 5k plus 3, not 2. So the right side is just 7k. So 10k equals 8. So k would be 8 over 10, which is 0.8. We can also write it as 4 over 5. Then we have to find U3. U3 would be 5k plus 3. So 5 times 4 by 5 plus 3, which gives me 4 plus 3, which is 7. That's the answer to part A. Now part B. To consider the case where k equals 12, we have to show that the first three terms form a geometric sequence. So when k is equal to 12, k minus 5, okay, u1 will be 12 minus 5, which is 7. u2 would be 3 minus 2 times 12, which is minus 21. And u3 would be 5 times 12 plus 3 equals 63. Right. Now when I do u2 over u1, I get minus 21 by 7, I get minus 3. And when I do u3 over u2, I get the same thing. 63 by minus 21 is again negative 3. So as u2 over u1 equals u3 over u2, right? Basically, I'm equating the common ratios. It is a geometric sequence with the first term as 7 and common ratio as -3. Fine. Now the next one is given that even if the geometric sequence, state a reason why the sum of infinite terms of the sequence does not exist. Yes, because the common ratio r, mod of r is bigger than 1. If the mod of r is in between 0 and 1, only then the sum of the infinite series will give you a finite value. Other than that, if r, mod r is bigger than 1, then you'll get an infinite value. So as is bigger than 1, the terms get bigger and bigger when they are added. They yield a value which tends to infinity. Done. Now the next one, sequence un is geometric for a second value of k. And we have to find this equation, k squared minus 10k minus 24 equals 0. So we can do again u2 by u1 equals u3 by u2 because they have clearly said that is geometric for another value of k. We can use this geometric series thing. The u2 squared is u3 times u1. u2 is 3 minus 2k. u3 is 5k plus 3. u1 was k minus 5. If I open the bracket on the left side, it becomes 9 minus 3 times 2 times 3 is 12k plus 4k squared, giving me 5k squared minus 25k plus 3k minus 15. If I shift everything to the left side, I get plus 9 minus 5k squared minus 25 plus 3 is minus 22, which becomes plus 22 on this side and becomes 15. Now, when I simplify this further, yeah, I get minus k squared plus 10k plus 24 equals 0. Yeah, I can multiply both sides with -1 and I'll get this expression exactly equal to this. Now the second part, you have to find the first three terms of un for the second value of k. So first, let's find the second value of k and then find the terms. So I'll try to factorize this thing. So minus 24 and minus 10, which is minus 12 and 2. Minus 12 plus 2 gives you minus 10. Minus 12 times 2 gives you minus 24. Plus 2k minus 24 equals 0. K times k minus 12 plus 2 times k minus 12, 0. K minus 12, k plus 2 equals 0. From here, either k minus 12 will be equal to 0 or k plus 2 will be equal to 0, giving me k equals 12 and k equals minus 2. K equals 12 is the old value given in the previous part. So k equals minus 2 will be the answer. Yeah. Now, it's not the answer yet. We have to find the first three terms. So u1 would be k plus k minus 5, so minus 2 minus 5 minus 7. u2 would be 3 minus 2 times minus 2, 3 minus 2k. Gives you 7 again. u3 would be 5 times -2 plus 3, which gives you -7. This is u1, u2, and u3, and that's the answer to part 2. Now the last one, and the value of s, yeah, it's s2m actually. The sum of first 2m terms for the second value of k. Fine. So here, we know that u1 is -7 and common ratio r is we can just do u2 over u1. 7 by -7, which is -1, right? So sum of nth terms will be u1 r to the power n minus 1 divided by r minus 1, right? So which gives me 7 times minus 1 to the power of n minus 1 by denominator would be minus 1, which is minus 2. This is Sn. Now, when we are doing S2m, it will be 7 minus 1 to the power of 2m minus 1 by minus 2, right? Now, thing is, 2m is an even number, right? So minus 1 to the power of 2m minus 1 to the power of any negative number would be 1. So this gives you 1. It will be 7 times 1 minus 1 divided by minus 2, which is 0. Therefore, sum of the first 2m numbers would be equal to 0. That's it. And that's your answer. Now, moving to the next question. We have 3 points ABC and D which form a parallelogram ABCD. And D is diagonally opposite to B. To find the coordinates of D, says, let's try to draw a parallelogram first. Kind of looks okay. Let's say this point is A, B, this point is C, this point is D, right? So thing is, to find coordinates D, I can equate AB vector and DC vector. So AB vector would be equal to DC, right? AB vector is like, to find AB vector, we'll subtract coordinates of B, like coordinates of A from coordinates of A. So B minus A basically, B vector minus A vector. So minus 3 minus 1 I plus minus 6, minus of minus 4 is plus 4, J, plus 2 minus 0, K. Yeah. And then for DC, it will be C minus D. For D, currently we'll consider it as XYZ. Just assuming it. We'll solve for XYZ. Exactly. So DC vector will be C minus D. So minus 1 minus XI plus minus 2 minus YJ plus 4 minus ZK. Now, AB and DC are parallel, right? So each of the I, J, and K component will be equal. So minus 3 minus 1 will be equal to minus 1 minus X. So from here, X will be equal to 3. Minus 6 plus 4, which is how much? Minus 2 will be equal to minus 2 minus Y. So from here, Y will be 0. And then here, 2 minus 0 is 2. 2 equals 4 minus Z. From here, Z will be 2. The coordinates of D would be 3, comma 0, comma 2. Done. That's it about part A. For part B, diagonals of parallelogram AC and BD. So AC and BD, they intersect at point E. We have to find the coordinates of E. So for a parallelogram, we need to know that E will be the midpoint of either AC or BD because diagonal like bisects each other, right? So we can just find the midpoint of AC and we'll get the coordinates of E. Midpoint of AC. Just add another page here. Yeah. So coordinates of E is coordinates of A plus coordinates of C divided by 2. So 1 plus minus 1 by 2, comma minus 4 plus minus 2 by 2, 0 plus 4 by 2. So E gives us 0, comma minus 3, comma 2. These are the coordinates of E. And that's the answer to part B. Now, AB cross AD gives you M minus 1, 1, and minus 1 again. So we have to find the value of M. Okay. So AB vector would be minus 4i minus 2j, 2k. Okay. And AD vector, when you find it, you get it as 2, 4, and 2. D minus A and B minus A will give me these two, yeah, these two vectors. You just have to find the cross product. I'll use the traditional way quickly, the matrix method. minus 4 minus 2, 2, 2, 4, 2. Give me I minus 4 minus 8 minus j minus 8 minus 4 plus k minus 16 plus 4 minus 12y plus 12j minus 12k. Yeah. If you take m like 12 common, you get minus 1, 1, and minus 1. Therefore, m would be equal to 12. That's the end of part 1. Next is we have to find the area of parallelogram. So basically, area of parallelogram is the modulus or the magnitude of AB cross AD vector. So AD, which is basically root under negative 12 squared plus 12 squared plus negative 12 squared. So this becomes 12 root 3, which is the area of parallelogram ABCD. Now next we have a plane, pi1, which contains ABCD, the Cartesian equation of pi1. So if a big plane contains our parallelogram, right? So AB cross AD, this cross product will give me a vector which is perpendicular to this plane, right? So for equation of plane, I need a vector which is perpendicular to the plane and any one of the points on this plane. Yeah. So equation of plane in Cartesian form, we can use this equation. So x naught, y naught, z naught is any one of the points on this plane, right? So we can take x naught as 1, y naught as minus 4, z naught as 0, which is basically point A. And ABCD would be the vector perpendicular AB cross AD, which is A is minus 12, B is 12, C is minus 12 again. So minus 12, x minus 1, plus 12, y plus 4, minus 12, z minus 0. So it's x minus x plus 1 plus y plus 4 minus z equals 0. So I divided both sides with 12, right? And then just open the brackets simultaneously. So this will give me x minus y plus z equals 5. So I'll shift 1 plus 4 to the other side, becomes negative 5, then divide both sides with minus 1. I'll get the equation of the plane. And that's it. That's the Cartesian equation of pi 1. Now the next part. The second plane has Cartesian equation 5x plus y minus 7z equals 1. We have to find the acute angle between pi 1 pi 2 is theta. Of course, we have to show that cos theta is 1 by 5. So direction vector of the first plane was I minus j plus k, right? Basically, it's 12i minus 12j plus 12k, but thing is, you can also just take the magnitude. It's fine. Or let's take the entire equation. 12i minus 12j plus 12k. Yeah. The mod n1 would be this will be 12 root 3. We already know the modulus value from the area, right? N2 would be the direction vector of this plane, which is 5i minus plus j minus 7k, right? So mod of N2 would be root under 5 squared plus 1 squared plus minus 7 squared. So which is root 75, which is 5 root 3. Now cos theta, it will be given by this formula mod n1 dot n2 divided by mod n1 mod n2. Okay, so dot product of n1 and n2 will be 12 times 5, 60, 60 minus 12, minus 12 and 4 is 84. Yeah, divided by 12 root 3 times 5 root 3. So 84, 96, it's 36 in the numerator. Negative 36 divided by 12 times 5 times 3. So you can cancel 12 and 3 in the denominator with 36 on the numerator. It will give me 12. Cancel this out. This is mod negative mod 1 by 5. So cos theta is just 1 by 5. Done. And that's how we have verified that cos theta is 1 over 5. Now the next one. There's a line that passes through E is perpendicular to pi 1. Okay, the line L intersects the plane pi 2 and F. Pi 2 at point F. Find the coordinates of F. You can just find the equation of line L and then just solve for L and pi 2. So for L, the direction vector would be the vector perpendicular to plane pi 1, which is minus 12y plus 12j minus 12k. The point or point E is 0, comma, minus 3, comma 2. Right? So equation of L, x minus 0 by minus 12 equals y plus 3 by 12 equals z minus 2 by 12. Negative 12, sorry. When you divide both sides with negative 12, you get, this is divided with 12. Minus x equals y plus 3 equals minus of z minus 2, which is 2 minus z, right? We'll assume this is equal to lambda. So x is equal to negative lambda, y is equal to lambda minus 3, z is equal to 2 minus lambda. Fine. Now equation of the plane is 5x plus y minus 7z equals 1. We can just place these lambda values in the equation of plane. This is equation of pi 2. And then solve for the value of lambda. So minus 5 lambda plus lambda minus 3 minus 7 times 2 minus lambda equals 1. So when we simplify, so 5 minus 4 plus 7 gives me 3 lambda. So you get 3 lambda equals 12. So lambda will be equal to 4. So when lambda is equal to 4, x coordinate will be minus 4, y coordinate will be 3. Lambda minus, wait 1 second, lambda minus 3. Yeah, so y coordinate will be 4 minus 3. Yeah, 4 minus 3 is 1, and the z coordinate will be 2 minus lambda. So 2 minus 4, which gives me negative 2. The point F would have coordinates minus 4, comma 1, comma minus 2. This is the answer to the last part of question 11. Now we'll move on to question 12. Okay, so we have a complex number z equals x plus yi, xy belongs to R, and then given that modulus z minus 2 plus I is equal to 3. So when I place z in this equation, I get this x minus 2, I times y minus 1. So modulus, so just do this. This should be equal to 3. Then if I square both sides and open the brackets, I'll get x squared minus 4x plus 4, y squared minus 2x plus 1 equals 3 squared, which gives me 9. So if I just rearrange everything, this is y, sorry. X squared plus y squared minus 4x minus 2y. It's the constant on the left side is 5, right side is 9. So when you shift 9 on the other side, becomes minus 9. So 5 minus 9 gives you minus 4, which is exactly equal to this equation. Done. Now moving to the next one. Argument z plus p is pi by 4. Z plus p divided by z minus 1 is pi by 4. To show that this equals 0. Okay, so this is going to be a long one. Replace z with x plus iy plus pn minus 1. Now, when you segregate them, you get this. So I'll multiply and divide with the conjugate of the denominator. Minus iy, x minus 1 plus iy. Okay. Now, yeah. Now if I simplify it further, I get x plus p times x minus 1 minus iy times x plus p plus iy times x minus 1 plus iy times minus iy. Divided by denominator becomes x plus x minus 1 squared minus iy whole squared. Okay. Now we have to expand everything, unfortunately. So x squared minus x plus bx minus p minus iyx minus ipy plus iyx minus iy and minus I squared y. Okay. Now I squared is equal to minus 1, so we can directly make it plus y squared, sorry. X squared minus 2x plus 1, and this will be plus y squared on the denominator. Now we can try to simplify, cancel this out. And if we rearrange, I'll get x plus y squared plus x times p minus 1 minus p. This is the real part. So I just break the real and the imaginary part. Minus py minus y divided by, because I is only on these two terms, x squared minus 2x plus 1 plus y squared. Now this is your complex number in x plus iy form. Now for argument, I'll do tan inverse imaginary by real part. Tan inverse imaginary part divided by the real part. Tan inverse minus py minus y divided by x squared minus 2x plus 1 plus y squared divided by x squared plus y squared plus x times p minus 1 minus p divided by x squared minus 2x plus 1 plus y squared. Now cancel these two out. We get tan inverse negative py minus y divided by x squared plus y squared plus x times p minus 1 minus p. This is argument of z plus p by z minus 1. So argument is pi by 4. So we can do tan pi by 4 on this side. Yeah. The right side would be py minus y divided by x squared plus y squared plus x times p minus 1 minus p. Tan pi by 4 is 1. So the left side becomes 1, and then I can cross multiply both sides to get this equation. And then when I shift everything to the right side and flip the equation, I'll get x squared plus y squared plus x times p minus 1 plus y times, if we take y common, it becomes p plus 1 minus p equals 0. This is exactly what we have to prove here. And we are done with this part. Now coming to the last two parts. Two roots are z1 and z2, right? So z1 and z2 will satisfy this condition. Find waves this results from part A and B to find z1 and z2. Okay, we can use the two equations which we derived, right? So here p is equal to 4. So when p equals 4, the first equation remains as it is. The second equation will become x squared plus y squared minus 4x minus 2y minus 4 equals 0. Basically, I just replace p with 4. So 4 minus 1 is 3, that's why you have 3x. And then 4 plus 1 is 5, that's why you have 5x on top, right? Now, um, from here, what we can do is we can just subtract these equations. X squared minus x squared is 0, y squared minus y squared is 0. 3x plus 4x is 7x, 5x plus 2y is 7y, plus 4 minus 4 plus 4 is 0. So from here, x plus y will be equal to 0. And I can also write it as y equals negative x. This is the equation which I derived from subtracting these two equations. Now I just have to put it in any one of the equations and solve, and I'll be done. So I can plug it in the first equation, x squared plus minus x squared plus 3x plus 5 times minus x minus 4 equals 0. Simplification gives me 2x squared minus 2x minus 4 equals 0, which gives me x squared minus x minus 2 equals 0. Now we can factorize this as minus 2x plus x minus 2, x times x minus 2 plus 1 times x minus 2, x minus 2 x plus 1 equals 0. Here you get two solutions, x minus 2 equals 0 and x plus 1 equals 0, giving you x equals 2 and x equals minus 1. Now, the first one, when x is equal to 2, y has to be minus 2, and when x equals minus 1, y has to be 1, because y is negative x, right? So z1 will be 2 minus 2i, and z2 would be minus 1 plus, and this is y, minus 1 plus I. These are the values of z1 and z2. And in the first part, we have to find z1 and z2 only, so that's it. Now coming to the second part, we have to find the value of a, this value, right? So we can use the sum of roots formula. So I know z1 and z2. The thing is, like z1, the conjugate of z1 will also be another root of this equation. This will be 2 plus 2i, and z4 would be minus 1 minus I. These are the two other roots, because if you have a complex root of an equation, this conjugate will also be a root of the equation, right? Now I know sum of roots would be equal to negative a, negative b by a. Here, b is basically a and a is 1. So it's negative a by 1. z1 plus z2 plus z3 plus z4 equals negative a. 2 minus 2i plus z2 is minus 1 plus I, z3 is 2 plus 2i, z4 is minus 1 minus I, negative a. Now add everything up, so this gets cancelled out, this gets cancelled out. Okay, so 2 plus 2 is 4, 4 minus 2 is 2, so a becomes negative 2 from here. And that's the answer to part D. And with this, we have finished on the paper 1. And I'll be posting the solutions for other time zones shortly. Thank you so much for watching this video. All the best and see you again soon.